So this is Pop Quiz 9, and again it is related to moles and structure. The first question, which combination of ions would expect to form a compound with the highest melting temperature? As I mentioned in the previous one, highest melting temperature means we want a strong bond, strong ionic bond. And strength of ionic bond depends on the size of the ions. Size of the ion should be small as possible. So size of the ion for a stronger ionic bond, small, and the charge on the ion should be large. So when we check lithium, it will be two, like for lithium ion will have one shell. And but why we don't bother about these two? Because if you check the charge, it's +1 and -1. But option B and C, there are ions with the charge +2 and -2. So we don't have, because the charge on the ion is the main factor rather than the size. So that's why whenever we see, we'll check which is having a greater. So either B can be an answer, C can be an answer. Now we check the size, which is having a smaller size. So when we draw magnesium ion, magnesium electronic configuration is 2 2 8 2 is there for atom, but ion it will be 2 and 8. And for oxide, it first shell 2, second shell 6 for oxygen, and then it take 2, so it will become oxide ion. So two shells are there. But for strontium and sulfur, so as we go down the group, the number of the shells increases. The charge is same, but they have more shells. So as greater number of shells are there. And for sulfur also, first shell 2, second shell 8, third shell 8 as well. So the size of the ion is getting larger. So as a result, what will happen? The attraction become weaker. Strength of ionic bond is weaker as compared to magnesium oxide. So magnesium oxide will have a stronger ionic bond. As a result, it will have high melting. So whenever you check the strength of ionic bond, check the size of the ion should be small as possible. Charge on the ion should be large. But what is the first criteria to check? First, check the charge rather than the size. Which is use of graphene based on electrical properties. Like graphene can conduct electricity and it is stronger as well. So drill tips are for diamond. It's not used for a graphene, it is for diamond. For pencils, what we use for pencils, we use graphite. It's not a use of graphene, it is a use of graphite. Touch screens use graphene, and that is electrical conductivity. So this is a use of a graphene and based on the electrical conductivity. Body armor also is a use of a graphene because graphene is also strong, having a greater strength. So it is used in body armor, but body armor based on the property of strength, not electrical conductivity. So C is the right option. Which molecule has the largest bond angle? For this, you have to recall the structure and the bonding, like how many bond pair and how many lone pairs are there. When we draw BCl3, boron having 3 electron, it share all the 3 electrons with chlorine. And when we are predicting the bond, when we are predicting the structure, we check the central atom. So central atom is boron, and how many bond pairs are there? 1, 2, and 3 bond pair. When 3 bond pairs are there and there is no lone pair, so then it will have a structure of a trigonal pyramid with a bond, trigonal planar with a bond angle of 120. So this will have a bond angle of 120. For carbon dioxide, carbon belongs to groups 4, so it shared 4 electron, and oxygen belongs to group 6, so it will share 2 electron. But when we predict the bond angles, like even a double bond or a triple bond are considered as one. So in terms of bond angle, this is one bond pair and this is another bond pair. Even though there are four bond pairs, but we consider them as like two if they are double bond or triple bond because it's a directional same direction. So while predicting a geometry, we consider them as a one bond pair. So this is one bond pair, this is another bond pair. So there are two bond pair and there is no lone pair. Whenever two bond pair and no lone pair, the bond angle will be 180 with a structure of linear. So this will be 180 degree and it will be a linear structure. For water H2O, hydrogen share one, oxygen share one, but there are two lone pairs on oxygen. So when a molecule is having two bond pairs and two lone pair, what is the structure? It has a V shape or a bent structure with a bond angle of 104.5 degrees. So this will be 104.5. And for ammonia, nitrogen share 3 electron, one with each hydrogen. So this has three bond pairs and it has one lone pair. When three bond pair, one lone pair, the structure will be trigonal pyramidal with a bond angle of 107.5. With a bond angle of 107. 0.5 is not there, 107. So the question was which is having the largest bond angle. So the linear structures will have the largest bond angle, which is 120. The 180, sorry, not 20. So you have to check, you have to draw the structure and check which is having the structure decide the bond angle. Linear structure is having the maximum bond angle. Then you have to complete a dot and cross diagram for sulfur dichloride. So sulfur belongs to group 6. Group 6 elements share 2 electron. Use dot for chlorine. So this is important. Like if they mention use dot for chlorine. So this is for chlorine, then sulfur. This is for chlorine and sulfur. And there will be 4 unshared electron as it belongs to group 6. Share 2. Unshared will be 4. Suggest the value and justify your answer. How to suggest a value? Like sulfur is at the center, so you will check sulfur. For a sulfur, how many bond pairs are there? How many bond pairs are there? 1 and 2 bond pair. How many lone pairs are there? 2 lone pair. So if 2 bond pair, 2 lone pair, what is the structure? The structure should be bent or a V shape. You can also say bent, and the bond angle is 104.5 degrees. And what is the reason for that? Because the lone pair repulsion is more than the bond pair. So the bond angle, if there are more lone pairs, the bond angle will decrease more. So answer here, like why it is having this structure. So we'll mention it has 2 bond pair, we already mentioned, and 2 lone pair. And the lone pair repulsion is more than the bond pair repulsion. Like when there are more lone pairs, they repel more than the bond pair. As a result, the bond angle will decrease. If all of them were bond pair, the bond angle will be larger. But because there are lone pairs also present, that's why the bond angle will decrease. Is it clear, this one? How to predict the geometry? So always check the central atom to predict the geometry of a molecule. So this was pop quiz 9, which was related to the bonding and structure.